Hello everyone, welcome back to another tutorial from Roadway VR channel. Today I'm gonna talk about one of the popular suggestion in the comments, which is reinforcement learning and sumo traffic signal. So I received these comments, for example, as examples, and based on the comments I'm making this tutorial. Uh, so for that, you will learn three main points. First one is the fundamental of the reinforcement learning algorithms, and then the second is developing two reinforcement learning algorithm, which is Q learning and deep Q learning in Sumo, and the last one is generating and comparing results. Okay, so let's jump to the first section of this tutorial, which is the fundamental of the reinforcement learning. Before jumping to the tutorial, I would really appreciate if you can subscribe to the channel. As you can see, around 90% of the visitors are the people that who are not subscribed to the channel. So by subscribing to the channel, it will help a lot. Uh, so these are the required materials for this tutorial. First, you need to make sure you have the Sumo, and then install the Visual Studio Code and installing Python. And then the last one is download the required codes from Roadway VR GitHub. So simply search GitHub Roadway VR and then go here and then open this Sumo traffic simulator tutorial. If you can just hit this star, then it also help me and other peoples to find this GitHub easier. So here, so what we are gonna cover is three topics, which is uh, these three codes, Tracy 5. Simply copy the raw file and then go here in, for example, download. You can create a new folder and then just making a Python code like this. Just open it and paste it, those informations here. So, and then maybe we can do this exercise two more times. So this first was the Tracy. Just follow the same name for the consistency. And then the second one is Tracy, the Q learning. And the last one would be DQ learning. And then for this one, I'm gonna just open it and then copy paste the informations in the Q learning and save it. And the last one is also copy pasting the code, deep Q learning. And then close this one as well. So we have now three Python files, and then we are this step is checked basically. Okay, so as you some of you may already know, the machine learning's classified in supervised, unsupervised, semi-supervised, and reinforcement learning. So the supervised learning on the left side, if I want to explain, is we have input data like cars, and then we have the annotations or output. We know already those are cars, right? So then we have algorithms here, the brain, right? And then we ask the algorithms that, okay, so if this is a car, and then the algorithm can say based on this training information that yes, it's a car. In unsupervised learning, we have input data. The algorithms, based on the similarities between these car, bicycles, scooters, it just classified these objects to different objects, right? In reinforcement learning, in other way, uh, we have a couple of states now. So first, starting from the environment. So if you observe here, this is an intersection, right? And then there is a traffic light there, and then we have a camera, right, in real world, and the camera captures the detects the car, right? And also we know the traffic light phase. So based on these informations that we call this as a state, right? The agents or the AI algorithms will decide that should it switch the traffic lights, for example, in this case, it should switch the traffic phase for this light so that these westbound and eastbounds can go faster, right? And then the traffic, uh, it facilitates the traffic, right? And then using this loop, it maximizes the reward. So the rewards here is the less amount of vehicles on the intersections, right? The less delay, basically. So this is how reinforcement learning does the job. Okay, so you remember I told about the state. So here we have state, right? We have AI algorithm, we have action, and the reward. So just remember uh, this loop. So in Sumo, in real world, we have inductive loop, the detector, which under the asphalts we put some detectors that detect car, and in Sumo those detectors called E1 or inductive loop, right? So if you just simply search inductive loop in Sumo, then it will bring this documentation E1. Just read these informations here, right? So this is the shape. So what it collects is vehicle count and vehicle speed. There is another detector in real world which is camera installed on the intersections, right? Uh, in Sumo we call it as a lane area detector. Similarly, go here and then search lane area detector, and it's called E2. Okay, and then it, in addition to vehicle count and vehicle speed, it also generates queue length and occupancy. The occupancy means the fraction of the time that detector area is occupied by at least one car. Okay, so in Sumo we don't have camera, we don't have these detectors, but at somehow using the programming we are replicating this behavior in real world. So this is state. Another one is agent, as I said. Agent is the algorithm, right? So the algorithm that we are gonna go is the reinforcement learning. We have model free, model based. Model based is you need to create a model first and then fit to the Sumo. For the model free is Sumo using the Tracy can figure it out the model from the start and then can further improve it. For the model free, we have value based, policy based. Okay, this is policy based. So the value based is working based on the integer value. The policy based is working based on probability. Okay, so this tutorial is gonna cover the value based, and then the two techniques are Q-learning and deep Q-learning. Okay, or deep Q network they call it. So for the Q-learning, just take this figure as an example. Uh, so let's say we have detector 1 to 3 here, right? And then 4 to 6 here. And we have a traffic signal also here, right? So this is the traffic signal phase, and then it has 0, 1, 2, 3. Currently it's in 0, and this is the duration, 42 seconds. It's in 0, right? And this R, G, Y means red, green, yellow, right? And each lane has a traffic signal on top of it, right? So those red, green, red, as you count, for example, these are 12, right? 3, 3, 3, 3. The 12 character is here represents those traffic light. And the action is keep phase or switch phase, correct? So then the first question is, what's the current state? So the current states right now using programming languages, right, is we have 6 detectors, right? So these are 6 numbers. So 0 means 0 car, 1 means there is 1 car. If it's 2 means 2 cars are on detector, right? So currently it's just 1 car. And that car is in detector 4, right? 1, 2, 3, 4. And then the last number here is the phase of this traffic signal, which currently is 0. Okay, then the next question is the action. What's the likely action that the algorithm might take, right? The likely action is just keep the phase because this car is the only car that we have, right? And then we don't want to make this red because we have 1 car here, right? So the action is 0. And what's the next state then? The next state remains the same because we didn't change this 0 to 1. We didn't switch. We don't want to switch the phase, right? And what would be the reward? The reward is -1. Why? Because there is 1 car there, right? So regardless, it's -1. So this is how Q-learning works, and then it has a Q tables and the Q values. So I will explain about these later. Okay, so this is one of the similar academic paper that Mr. Chen, I guess, he and their team is using Q-learning and deep Q network or learning, and then using Sumo to compare some scenarios. So this is a very nice, by the way, figure from the paper. You can just simply search this paper and then read the paper. So it has a Q-learning, deep Q network or learning, right? And then as you can observe, there is a Sumo traffic lights here. It goes to these Q tables and then get back actions to the Sumo, right? Similarly, instead of just this Q table in Q learning, we have a neural network, which is deep Q learning or deep Q network, they call it, right? So we're gonna go through this type of works.